Welcome everyone to the third video of this chapter. We're going to be working on section 4.3. We're going to be talking about side, and the side, angle, side congruence postulates. So our objectives for today are to prove that triangles are congruent using the side, and the side, angle, side congruence postulates. Okay, so in section 4.2, we started looking at different triangles, looking at the congruency between sides. And one thing that we started to notice is if we have a triangle and all the sides are congruent and all the angles are congruent, we could conclude that those two triangles are congruent to each other. So in this section, we're going to take that concept a little further and get a little more specific with our properties of triangles. So the first congruence postulate that we're going to look at is the side congruence postulate. And this postulate tells us that if three sides of one triangle are congruent to three sides of a second triangle, then the two triangles are congruent. So here I have side MN and side QR. I have side NP and I have side RS, and then I have side MP and side QS. So you can see by the congruency mark, these three sides are congruent to these other three sides. So these two are congruent to each other. Second one we're going to learn is called the side, angle, side congruence postulate. So this one is a little more specific, and I want to highlight one keyword right here, included. So if we have a triangle and if two sides of the included angle of a triangle are congruent to two sides and the included angle of a second triangle, then those two triangles are congruent. So I want to highlight included because let's say, for example, we're talking about side PQ and WX. We're good there. We know those are congruent. Then we know that QS and XY are congruent. Now, it needs to be the included angle. By included, I mean the one that's in between them. Okay? So, for example, if P and W were congruent and these weren't, if angle Q and angle X were congruent, this wouldn't work. It needs to be the included angle. Okay? So, once again, if two sides and the included angle of one triangle are congruent to two sides and the included angle of a second triangle, then we're good. We can say those two triangles are congruent. Okay, so we're going to informally prove that triangle ABC is congruent to DEF. So the first thing that we know is that side AB is congruent to side DE. And we also know that angle B is congruent to angle E. And we know this because of the marks on the diagram, because the B has this line here and the E has this line here. And finally, we know that side BC is congruent to side FE. So we have a side, an included angle. Notice that it's the angle in between the two sides. And we have another side. So these two triangles are congruent because of the side, angle, side congruence postulate. Okay, so let's look at these two triangles that are connected to each other to form the square, rectangle, if you want to call it. And let's see if we can state the congruence postulate that would help us prove that these two triangles are congruent. So, first thing I like to do is I like to mark these corners just so it can give me some reference point of what I'm working with. Next thing I like to do is I like to break these into two different triangles, because there's something that's easier to see if you break these up. Okay, so we know that side AC is congruent to side BC, and we also know that BC needs to be congruent to itself because of the reflexive property. Now we know that side AB is congruent to side CD. So if we have two lines that are congruent to each other and they're cut by a transversal, what do we know about these two angles? We know those two angles are congruent because of alternate interior angles. So same thing here. This line is congruent to this line. Therefore, we know that this angle is congruent to that angle. So we'll mark that in our diagram over here. And that works out for us perfectly because this is an included angle to our two congruent sides. So we could say that AC is congruent to BD. We know angle ACB, I'm talking about that first top triangle right here. Angle ACB needs to be congruent to angle CBD. And finally, we know that side BC is congruent to itself. So, because of the side, angle side congruence postulate, we know that these two triangles are congruent to each other. Okay, so let's look at this and decide whether enough information is given in the diagram to prove that triangle PQR is congruent to PSR. If there is enough information, let's state the congruence postulate we would use. Okay, so once again, I think it's helpful to break these up. And you'll find that when we do a lot of these, breaking them up is always going to make it easier for you. That's our goal here. We want to make our lives easy, not difficult. So I broke up this triangle on the left. Let me break up this triangle on the right. Then mark up what I know. I know that QP is going to be congruent to PS. I know QR is going to be congruent to RS. And once again, this side right here is the same as this side. So look at what I have. I have 3 sides and 3 sides. So this would be the side congruence postulate. Good job. Okay, once again, let's quickly go through these. I think you're doing pretty well with these, so I'm just going to focus on number 3, number 5, and then actually take a second, pause the video, and see if you can work on these, and then I'll put the answers back on for you in a second. So take about a minute, work on these, and then when you come back, I'll give you the answers. Okay, so let's quickly go through these. For number 3, you have 2 sides, so you know this side is congruent to this side, and then you know YZ is congruent to XW. Once again, if we were to break these up, we would see that XZ is congruent to itself. So this would be the side congruence postulate. Same thing here, guys. Break these up. It'll be easy for you to see. If we were to break these up, you see that this side is congruent to this side. AE will be congruent to itself. And then we have this angle here. Now, is this enough to tell us that these two triangles are congruent? Remember the definition for side, angle, side. You can think about it this way. The angle needs to be in between the two sides. So, if the angle isn't between the two sides that are congruent, it won't work. And if we look at our image down here, we can see the angle is outside of the two sides. So for this, there's not enough information. So not enough information. Now that being said, let's say it was this angle that was congruent. Then that would be enough because that's in between our two sides. So if writing SAS helps you, do it that way. Okay, so let's break these two triangles up. So we have congruent here, marks here, and once again we know that this side KJ needs to be congruent to itself. So for this we're good because this angle is in between the two sides. So maybe even write it like this, right? Side, side, and then if the angle included is congruent, it should be good. All right, let's get to some proofs. So let's look at what's going on in our given, think about what we're trying to prove, and see how that corresponds to what we have given so far. So the first statement we're given is that O is the midpoint of MQ. And as you can see, that's given to us. So far so good. Now it's talking to us about the definition of a midpoint. Now I want to remember that if we have any segment, line, anything like that, and I tell you that it has a midpoint, then you automatically know that these two segments need to be congruent. It's a midpoint, it splits it in half. So if in the first statement we're talking about segment MQ, that means we're talking about this segment right here. So the proof wants us to talk about the two segments that it's making congruent. So we can see that segment MO needs to be congruent to segment OQ. And I think I'm going to write 3, 4, and 5 down here just to give myself some space. Okay, so next thing we want to do is look at our given. Another one, our given is that O is the midpoint of NP. And then same thing, it's asking us to define that midpoint. So let's define what's happening with this line NP. Well, NP is getting broken down into these two congruent segments here. So we know that NO needs to be congruent to OP. Okay, now we're at step 5. So now it's telling us to look at this angle right here, MON. MON is this angle right here, and QOP is this angle right here. How could we possibly know that these two angles are congruent? Well, we know that these angles are vertical angles. And what tells us that these two angles are congruent is the vertical angles theorem. So finally, let's look at what we have here. We have one side, two sides, and this included angle. So we have a side, angle-side congruence postulate that tells us that these two triangles are congruent. Okay? Alright, now let's talk about some paragraph proofs. Now we haven't done much work with paragraph proofs. It really is very similar to a two-column proof. The only difference is that it's just in paragraph form. So I'm going to give you some bullets for this, and then we'll work on doing some paragraph proofs in class. But it's really just a less formal way of doing a two-column proof. So very similarly, I'm going to state my givens. So I'm going to say that AB is congruent to CD, and BC is congruent to AD. So I know BC is congruent to AD, and BC is congruent to AD because it's given. And once again, similar to proofs, there's not just one right way to do this, but there are specific things you need to include in there. Okay, so now we've stated that AB is congruent to CD, BC is congruent to AD, and once again, we can break these triangles up, and that's going to help us to see that AC is congruent to AC. So we'd say AC is congruent to AC because of the reflexive property. So let's see what we have. We already have 3 sides, so now we can say our final conclusionary sentence. So we can say that triangle ABC is congruent to triangle CDA because of the side congruence postulate. Bam. All right, last proof. We get no statements and no columns. This is all us. So, first thing you're going to do, whenever you get a proof, make your statements and reasons column. You got to start somewhere. So similar to the last section, I'm actually going to start this one, and then I want you to try finishing this on your own, and then we'll go over it together in class. Okay, so this is very similar to the proof we did earlier in class, except that now we got to put it in statements and reasons. So, first statement. Let's state our givens. So we know AD needs to be congruent to CB. And we also know that AD is parallel to CB. Reason for this is given. Okay, this one's very similar to the other one. Since these two lines are parallel, we can conclude a few things about these angles. So, by looking at these angles, we know that these angles and these angles need to be congruent because of alternate interior angles. So, I'm going to say that angle ADB is congruent to angle DBC. And the reason for that is because of alternate, and I'm abbreviating because of space, but alternate interior angles theorem. Okay, I'm going to leave it at there. I think you guys can finish it from there. Okay, and that's our lesson. So work hard on that last proof. Go back, put a star next to any questions you have, and we'll go over the lecture notes together in class. All right, I hope that was helpful. Thank you.